Hello! I would like to do an experiment with you today, something that can easily be done at home. You'll need the following equipment. First, you'll need a bucket of water. You're going to need a piece of steel wool. This is just a piece of metal, steel wool, okay? A 9-volt battery. A safe place to conduct your experiment, so something that's not going to be flammable or catch on fire. In this case, I have taken aluminum foil and covered my table. You're going to also need safety goggles. Now, it may not seem in this experiment that you should need safety goggles, but I highly suggest you always wear them, even if you have glasses like I have on, because these are not safety goggles. They will not protect your eyes from any kind of flying debris or chemical spill or anything like that, and these will. So anytime you do an experiment, you really need to protect your eyes. Your eyes are very delicate. You also will need to have a parent or guardian help you if you're under the age of 18. That's very important, so you're going to need their permission and their help as well. Now, what's really neat about the experiment we're going to do today is that I'm actually going to take and light this steel wool on fire. I want to talk a little bit about what fire is first. You see, fire is the act of oxidation, right? That's really what it is. It is turning something like wood or paper, you burn it and you turn it into carbon and carbon dioxide. And you do this through the introduction of heat and oxygen. Now, we're very used to things like wood burning or paper burning, things like that. Imagine your house. But metal? Well, you see, whenever you burn wood or paper, what you do is you have these complex carbon molecules, and they get broken down. And that heat breaks those bonds apart for the carbon, and it recombines with the oxygen, making carbon dioxide and then some kind of carbon leftover residue, like graphene, nanotubes, diamonds, sometimes even. But you can burn more than just wood or paper and carbon. You can in fact burn steel wool, because inside of steel wool is iron. And what I'm going to do here is I'm going to actually take and turn the iron in here into iron oxide, all right? And that is going to come up a little bit in the smoke, but it's also going to be left behind here in the iron, and that is actually what's going to be burning. Now, the term oxidation itself doesn't necessarily mean it needs to use oxygen like it might suggest. It's actually a process where something gives up electrons. So in fact, the universe's best oxidizer, as far as we can tell, is actually fluorine and not oxygen. Now, fire or oxidation requires three things. First, it requires fuel or something to burn. Second, it requires some kind of oxidizer, in this case oxygen that's in the air. And finally, it requires heat. So in other words, there has to be enough heat for the oxidation reaction to occur. If I deprive the fire of any one of these three things, it will go out, which is why pouring water on a fire works very well. You deprive it of both heat, because the water cools it off, and you deprive it of oxygen, because although there is oxygen in water, it's not something that the fire can actually use. And that is why this bucket of water is so important, because it is what we are going to use to put out the fire whenever I light the steel wool. Now, in order to get this steel wool to burn, I will have to get it hot enough. And in order to do that, I'm going to use this battery. You see, steel, like the copper wires in your walls to make your lights turn on, will conduct electricity. But steel doesn't conduct it as well as the copper in your walls. So it has what we call a higher electrical resistance. That means that it will get hotter to push the same amount of basically current through it. You see, this is made up of iron and carbon and other elements, while copper is pure just copper. And all of those extra elements and stuff that I add to steel, well, what happens there is those create special little boundaries, like places for the electrons to bump into. And every time they do, they release energy. And so it's harder to push electrons through steel than it is to push them through copper, and so the steel gets hotter. That's what resistance does. It will make it get hotter. All right? Second, and this is also important, this steel wool is very fine. You see how nice and soft it is? It's actually got this very fine little fibers in here, as you can see. And those little fibers, that's where the electricity is going to be moving through. All right? And because they're very small, it becomes also really hard to push a lot of electricity through them. And so these fine little fibers also have a higher resistance than, say, a bigger fiber or a really big pipe or tube or something. You can imagine that you might have a piece of steel. Okay? So what I'm going to do is I'm going to take this battery and I'm going to put these two terminals in contact with the steel wool. And so electrons are going to move from one terminal to another through the steel wool, and as they do, it's going to get the steel wool hot. So I'm ready to start this. And so now I'm ready to basically start burning this, except for one thing. I'm not wearing my safety goggles. So let me go ahead and put those on first before I conduct my experiment. Make sure I'm nice and safe. There we go. That's the last bit of safety equipment I need, and I'm ready to go. So I have this battery and I have the steel wool, and what I'm going to do is I'm going to touch the battery onto the steel wool like this, and you see it gets to nice red hot, white hot flames. And here we go, burning steel. This is in fact how fireworks work as well. The steel burns a nice orange. In fact, if it was another element like copper, it'd burn a different color. When I want to put it out, I just put it in the water, pull it out, and it's out. And that's the end of the experiment. Well, I hope you enjoyed the video today and watching me burn steel wool, and I hope you learned something. If you like this channel or you like this video, please like and subscribe to my channel for more content. And I hope everybody has just a wonderful rest of their day. Bye-bye. This has been a video from Van Cleve Scientific. If you like this, please like and subscribe for more content.